Okay. Oh my goodness. Computers. Okay. Welcome to another episode number 3 of Let's Code Up a little silly little game. So, when last I left you, I had. Alright. A game, so when I press up and down, I make a little box move. Isn't that great? That's pretty cool. So there's a couple things that I need to fix. One is, why the heck am I... Where is it? Yeah, this right here. Why am I basing the height of the canvas on the height of the screen? Shouldn't it be a fraction of inner width so it's constant? So if I make the browser window really narrow and tall, it doesn't make the game screen really narrow and tall. Instead, it stays like a good ratio according to the width of the browser. Isn't that what I want? So I'm going to make this look a little better. I'm going to build this guy. A little too tall in my opinion. It's probably fine. I'd also like this to be a little wider. Maybe 9.9. Let's see if that looks good. Waiting for it to compile. See, I don't know why this happens. The border. I mean, obviously, if I don't have a console. Nice. See, even here, the border is really tiny. Or you may not even be able to see the fact that there's a border here. Okay, so getting the console to pop up again. And I don't care about favicon. So I'm going to do something like that. I just want to get the game screen to look nice. That's all I really care about. And I think that's probably fine. Okay, so now that that's figured out, the next thing is, I talked about how functional programming was so much better than procedural or object-oriented code because everything looked like a math equation. And what I mean by that is that your application kind of looks just like a big mathematical function where you put user input in and current application state into the application, and you get out new application state. In this example, I want to input arrow keys, and then the new state is the box is in a different spot. But right now what I'm doing is I'm actually modifying state, so that's no good. And truthfully, if I was a better programmer, I shouldn't have even done this intermediary step. But be that as it may, I'm going to use something called scan. And what scan does is it acts just like reduce. Now, if you're not familiar with this, well, oh, right. That's not what I wanted to do anyway. All right, so let's say I have a list. 1, 2, 2, 3, right? I'm going to name it list equals. All right, so I've made a list. Now, what I can do is reduce it. So I'm giving, oh, it's not quite right. all lists, all arrays in JavaScript have this reduce method, and I can give it a function. Right? So what have I done here? I've taken every element in the list and I've applied a function to it. The first argument in this function is what's called an accumulator. How can I put this? I don't know if I can really explain it and do a let's code at the same time. But the idea is that the first time this is called, I'm going to be adding 1 and nothing. The result of that is going to be 1. The next time this is called, it's going to be 1 and 2, and the result of that is going to be 3. And the last time I call this, it's going to be 3 and 3. The previous value is x. The new value is y. So the idea here is the same with scan. The previous value is well, I've got an accumulator. That's my x. And I've got arrow, which is my y. And I'm going to do basically this. All right. Only instead of modifying stuff, scan is going to return. How can I put it? So you know how I took those values 1, 2, and 3 and I sort of smushed them all together using that function? Imagine if instead of giving 1, 2, and 3 all at once, all at the same time, I got 1 at a certain point, and then sometime later I got 2, and then sometime later I got 3. So the first time I get a value, I get 1, I apply the function, and now I get this value, 1 plus nothing is 1. All right, so sometime later in the application, I get 2, and I add that to my accumulator. Now 1 plus 2 is 3. Now the value is 3. That's application state. And then sometime later, I get the value 3, and I add that, and that's 3. And maybe sometime later, that's 6 rather. The accumulator value is 6. So what keeps happening is over time, I get these values, and in our case, it's arrow up and arrow down. These are our values. These are our elements of our list, and the list keeps growing in size because I keep pressing the up arrow and the down arrow. And what this scan does is it takes that arrow that I'm giving it, and it's going to somehow add it to the accumulator, and scan is going to keep track of this accumulator value. And every time a new arrow comes in, it's going to spit out the current accumulator. So the first time I would get a new element in the list, it's gonna spit out the current value of the accumulator, and I can use that in subscribe. In fact, I'm going to get box, right? That's what I'm gonna get. And instead of this, I'm returning a value. So scan is going to smush arrow and accumulator together. So I'm returning an object that's just like box. Check this out. Box. Except that y, it's not equals, box. Let's see. That's what that is. Check this out. All right. And so this is why I wasn't used to using break in my switch case statements, because when I'm using switch case lately, I'm doing something like this. I'm returning from every case. And I also make sure I always have a default. So if I get something that's not arrow up or arrow down, later on, I'm just going to return box. Now, some of you guys may recognize this as the Redux pattern. Why don't I just use Redux? I could. I just find this easier. All right, so with this dot dot dot, it's going to take all the keys and the values of box, and it's going to just sort of insert them into this object. And the only thing that's going to change is the y value. So it's a way of creating a copy of an object with some minor change or some other change. And that way we can write things in a functional way. Scan is going to kind of keep getting these arrow values, and every time I get a new arrow value, I'm going to spit out a new box with a slightly different values. And I can do things later. If I decide later I want to make a game where I change the x values, I could do something like that with x. I can do all any change I want. But the point of this is to keep our functions relatively pure, or our code relatively pure. There is one thing that's different here, is that scan retains this box state, this accumulator state, and that changes every time scan gets a new value. We get a new box, but it retains the old box and combines that box with a new one. So you could argue that that's changing state, mutating state. And also this guy here, this is creating a side effect. It's not just returning a value, it's actually doing something with our code. But eventually you have to do something with your values. Otherwise, why run the code? You have to have side effects. Not all of your code can be a mathematical equation, because nothing will ever happen if that's the case. So hopefully that, I don't know how much that explains what I'm doing. And I need to start this with box. That's an initial value. I think this is all I need. I could be completely wrong. Sure. Oh no, it's not compiling. Oh. There we go. So this was the ending curly brace for the switch statement. I still need the ending curly brace for my function. That should do it. I'm not actually using my desk. I'm actually sitting on my bed this time, so there's a rustling of me changing my legs up so they don't fall asleep. All right, so that compiled. All right. Uh-oh. Up, down arrow goes up. It's because I don't do a plus here. Okay, cool. And I'm going to extract this guy. Game. I'll explain what I'm doing here in a second. I'm always so self-conscious of how quiet I tend to be while I'm thinking about stuff, because I'm used to just course, just programming on my own, on my lonesome. And so I don't need to constantly explain what I'm doing uh, and try to be entertaining or educational. I just write code. And so sometimes when I'm looking at the code, I'm trying to figure out what did I write down? What am I making this do? Or, what do I need to do next? So I'm just extracting these. This is the initial value for our scan. And this is the, the game function, as it were. This is really the game logic. So this should start up the stream immediately before any keys get pressed. This start with should just sort of jumpstart the game with the box value. It gets put in here. Nothing changes because, oh yeah, this is what I want. Yeah, I think this is what I want to have happen. Yes. So the whole point, what I'm trying to do right now is just to, without actually pressing a key, I want the initial box value to sort of be pumped into this subscribe. So I don't actually have to press a key in order for the box to appear. And that'll cause this code to be run, right? So it'll clear the rectangle, it'll clear the game screen, even though the game screen doesn't need to be cleared, and it'll draw the box. And then I don't have to have that same code up here drawing the box. I just sort of jumpstart it with that extra little bit in the stream that starts everything going. So this is the engine that sort of runs everything. I get a stream of keys, I filter them. This is where the game logic happens, where we take user input and previous game state and smush them together and output new state. This is the initial state. This start with box. And this is what we actually do. As soon as we get game state, what do we actually do with it? We draw to the screen. So if I've got this right, let's see if I've got it right. Compiling. All right, well, at least it doesn't break. Start with is not a function. I know it's start. I know there's a way to make this happen. RxJS. Starts with. Is it starts with? So there's an S. I've done this before, I swear. Come on, compile. All right, let's see what happens. See, it is a start with. Okay, so that's... Why don't I just start with an empty string here? So this would just trigger. Oh, geez. That is not a noise that should have happened. My phone was on silent, I swear. I swear there's a way this is supposed to work. I may have to pause and do a bit of research. See, look at that. As soon as I pressed a button, I saw it appear. Actual size, please. Something gonna happen? Okay, here we go. Start with. There we go. Oh, it's gotta have a capital W. Let's see what happens here. All right. Sweet. All right. So we get our keys. So first we get the event stream, which is just a bunch of objects, each object representing a key press. Then we, from each object, just grab the key, the actual value of the key that's being pressed, whether it's an up arrow or a down arrow or the letter F or whatever. Next we filter out only for arrow up and arrow down. That's all we care about for this game. Then I start things off by giving the stream an empty string. And the reason I do that is so that this default gets triggered and we get things started, right? So if the stream of values being given to our game, if one of the values that being given to our game is just an empty string, it'll trigger default right here and just return initial game state value, and it'll just send that to our subscribe. Our subscribe clears the screen, draws the box, and we're on our merry way. Next time something happens, next time a button happens that, like if I press, for example, F, I'm actually making the game do something. The game hits default. It actually runs this bit. In fact, I can prove that. Okay, come on. All right. Do nothing. Hey, it says do nothing. So I press F. Oh, you're gonna make me a liar, aren't you? Oh, jeez. Oh, I know why. So it does do nothing initially, but because I'm filtering out all the arrow, everything except for arrow, that never gets called. Okay, that's fine. It's good, so I actually know what my own code does. Jeez. So this is the engine of the code. But what's nice about this is I've got it all set up so this scan, that's where all my game logic is going to go. I've got an initial value of my box, and I've got the game. Smush those two together, I get new game state. Keep doing that forever. So all I have to do now, because this is written in this nice functional way, all I have to do is write this game function. That's it. This is where all the game logic is going to live. If that function gets too big, I can create more functions that'll be called in here, right? So I can make my entire game a sort of function, a mathematical function. It has an input, it has an output. That's all that it does. It just whatever input you give it, it's going to give it the same output. And I can make this initial value much more complicated. I can include any information I need about my rocket. I can include any information I need about asteroids that are showing up. That this game itself can take that game state, which includes the position of the rocket. It includes where the asteroid's at, and it'll move around. Now later on, my plan is to, in addition to getting keyboard information, I'm going to want to get probably some sort of clock going on, and I'm going to want to merge that with the keyboard information, so I have some tick of the clock in addition to my arrow keys, so I can switch that into one stream that gets handled by the game logic. I'll put another case in here, probably for tick. I'll do something like this. And that'll represent a tick of the clock. That'll come in every n seconds, or every nth of a second, or whatever it is, and I'll do something like move the asteroids some distance forward. And that's all. This is how the game will be built. And what's nice about this, as opposed to some other way of handling game logic, like in the object-oriented world, a rocket would be its own object. You would create a rocket, instance of a rocket, a class, and that rocket would have its own methods, and you'd have the same thing with each asteroid, and you'd probably have some sort of collision detection that would occur between the two, where one called it would be just a big mess, and state would be everywhere. Here, I'm taking state in, I'm taking input in, and I'm outputting new state, and it's nice and clean, and there's only one in and out entrance and exit for how things work. So it's really nice, and I think as I continue to code this up, you'll see how nice it's going to get. So feel free to let me know how I'm doing, if this makes sense to you, if certain things need to be explained better, and give me questions in the comments. Subscribe, because I plan to keep making more of these videos, and like this video, because I think that helps me somehow. I don't know. I think that's what it does. It helps me in some way. I'm just gonna run this guy, make sure it continues to work, and I'm gonna end the video. Yeah. And it does pretty much the same thing I did before, but I'm in a much better place. I'm much better prepared to write the rest of the game code. So thanks for watching, guys. I'll talk to you later.